Standard Industrial. We created a series of tutorials to make sure that you have the information needed to get the most out of your Standard Industrial equipment. When you're done with these lessons, check out the other skill building videos on our YouTube channel, and thank you for choosing to make Standard Industrial part of your business. In this lesson, we'll learn to enter a punch into the tooling database. First, move to the tooling database. Look in the upper left-hand corner to verify which tooling list you're in. Toggling the tooling database icon will move you back and forth between the punch list and the die list. Because we're entering a punch, we want to begin with the punch list. At the bottom of the screen, there are a variety of buttons that say Type 1 through Type 4. Each of these are pre-made templates that allow you to enter a particular punch in a certain style. So if we select the Type 1 template, we see that it is a gooseneck punch with an arced relief in the back side of it. If we're using that type of tool, then we simply fill in the information for each characteristic of the punch, and the punch will be drawn. The Type 2 template is for faceted gooseneck punch. The Type 3 template is for a double relieved gooseneck punch. And the Type 4 template is for a radial punch. If your punch doesn't match one of the template types available, or you'd like to simply draw it from scratch, then select New Drawing. When starting a new drawing, the first thing you'll be prompted for is the total height and the reference height of the punch. Total height for the punch includes the height of the tang. The reference height of the punch does not include the height of the tang. On standard industrial machines, the total height is not used, only the reference height is used. So, it is our recommendation to reduce the possibility of error that we enter the actual reference height of the punch for both of these values. In our instance, the reference height of our punch is going to be 3.5 inches. So we're also going to enter the same value for the total height. Once we click OK, you'll see that the dotted line here establishes the crude dimensions that we will find the punch fitting within. The drawing starts always on the left angular face of the punch. Here you'll need to know the punch dimensions from the tooling drawing that your tooling provider supplied you. In the case of our punch, the first angular face is 1 inch in length. Here, where we enter information, whenever you see an L, you're always being prompted for the length of a particular segment. So we see that the L is highlighted, and it's asking us what the length of this particular face is. So here, we'll enter 1 inch. Next, it's asking for the angle of the punch. This diagram attempts to assist in helping you understand what's being asked for, and here we are being asked for the actual angle of the punch tip. Our punch data indicates that this is an 85-degree punch, so we'll enter 85 degrees. Next, as indicated here with the S, we're being asked whether or not this is a square tip punch or R for a radial tip punch. In this case, our punch is a radial tip punch, so there will be no value entered for square tip. Now, as we enter the radial tip punch, we need to tell the control what the radius of the punch tip is. And in this case, we have a 1/8 inch radius punch, so 0.125 indicates a 1/8 inch radius punch. Next is the load. The load is the amount of force that that tool can withstand safely. This is information that should be provided by your tooling supplier and should not be estimated. The control uses this value to prevent operators from exceeding the maximum force of the tooling and placing themselves in a dangerous situation. Please make sure that this information is entered accurately to ensure the safety of your operators. In this case, our punch load is 22 tons per foot, and please take note that that information should be entered in tons per foot. Now, take note of what you saw on the screen. After I entered that load information, it appeared that the data vanished. This section scrolls vertically, so as you enter information, the preceding information scrolls off of the screen. You can also see that in our drawing we have progressed automatically to the next face of the tool. If you need to go back and edit or review something, you can simply hit your back key and you'll see that that information scrolls back into view. You'll also notice that correspondingly the red highlight moves to the line or to the feature that's currently active. So we're now back on the first line. The data has scrolled back onto the screen. We're going to move forward again. We'll see that the current segment that we're drawing turns red, and now we're being prompted again because we see an L. It's always asking us for what the length of the segment is. Because this is a symmetrical punch, each of these faces of the tip are going to be the same. So this face is also 1 inch long. Next, we see alpha. When we see an alpha, it's always asking us for an angle or direction. In this case, it's asking us which direction the next line needs to go. And because this is a symmetrical punch, the next line is a vertical line. When entering information about line directions, you have several options. You'll see that each of these arrows represents a fairly standard direction. In this case, we're going straight up, so we can hit the up arrow and it'll automatically insert a line direction for us. Now that it understands which direction we're going with the line, it wants to know again, well, what is the length of this line? And in this case, this side is 2.75 inches. The same question is asked again. Now that we've drawn that segment, what direction do we want to head? Again, asking for an alpha. This time, we're going to move to the left. Once again, we now need the same old question. How long is this line? And in this particular case, the punch is 1.35 inches wide. Now we're at a point where we're ready to close the drawing, which means that we're drawing the last line segment that will complete the drawing. To make this easy and to do the mathematical rounding necessary to meet the controls requirements, there is a feature built in that has a button here called Close Drawing. Hitting Close Drawing will draw that last line for you, and it will enter the value necessary to close the drawing out mathematically for the control. To save the punch, move to the computer icon and select an alphanumeric name that is 30 characters or less. And select OK. Select OK again, and your punch is saved. To validate that your punch has been saved correctly, move to the tooling database. Make sure you're in the correct list, so let's toggle to the punch list by clicking the database button again. And here we find the name of our punch, and we're shown some basic information: the name, the height, the angle, the radius, and the load of the punch. If you wanted to go back in and alter the punch, you could simply hold down on the punch and it enters back into the drawing mode so that you could make alterations. At this point, your symmetrical punch is completely entered and saved, and you're ready to move into production mode. I hope this tutorial has been beneficial, and if it has, we need to ask a favor of you. In order to keep this site visible and to continue to bring this material to you for free, we need you to become a subscriber. We promise if you do that we will not send annoying solicitations to you. The only time you'll receive notifications is when we post new material to the site. So please subscribe, and thank you again for choosing to make Standard Industrial part of your business.